Hi everyone, my name is Olivier Lefebvre and I'm with Climate Solutions Consulting. And today I would like to talk about stove use monitors and how we can use those sensors to better understand the contribution of different sources of PM. So let's talk about cross-sensor analysis and specifically about two sensor types, the stove use monitors and light scattering PM sensor. And on their own they can provide a lot of very useful information. But when we analyze them together, we can get extra insight that we didn't have otherwise. And this is kind of free insight because we don't need to put extra hardware in the field. There is, of course, quite a bit of analysis that needs to be done, extra analysis, and that could be typically pretty hard to do when you have sensors that are completely independent from each other. But in my case, it's a lot easier because I've used the Apex and the Exact, which are sensors that are fully integrated, that provide just one file and for which the data is available with a shared time series. For the purpose of this presentation, we'll do a quick case study. I wanted to present to you the protocol. So we had, in the study, we had 90 households divided in 3 groups, 1 control group, 2 intervention groups. They used only firewood and had 2 to 3 stoves per household. So we carried out a KPT during 4 days. We placed exact stove use monitors on all the stoves in the household during 6 days. And we also had Apex PM sensor in the kitchen and on the cook during 6 days. On top of that, we had also collocated gravimetric sampler worn by the cook during 24 hours. And that's an example of the data we get at the household level. So on the left y-axis, you have the temperature from the exact sensor, and that's the orange trace that we see here. The blue trace is for the baseline stove, and the green trace, you see the unit on the right, it's the personal exposure of the cook expressed in microgram per cubic meter. On the x-axis, we have the time. And so that's one example for one household for a couple of days. But when we look at the 30 household over the 6-day period, this is one example of the chart that we can get. And on the left, you have a chart that sensitizes the use of the stove throughout the day per stove type, and so that allows us to understand when each stove are being used. And we see that the intervention stove is the main stove that's being used, but there's still quite a bit of residual use of the baseline stoves. On the right, we have a graph that summarizes the PM measurements, and it's the average PM in microgram per cubic meter measured throughout the day through 15 minutes intervals. So we can see that this PM exposure is kind of aligned with the stove usage, which kind of makes sense. And so yeah, that's what we get. If we analyze independently, on one hand the stove use monitors, on the other hand the PM light scattering sensor. And that's great, that's really useful, that's a lot of useful information, but if you just stop here, you actually leave a lot of very interesting data on the table, and so that's why we can get a little further. And so let me walk you a little bit. So this slide is quite dense. If we start at the bottom with the y-axis, this is the time. On the left we have the temperature of the stove, and on the right we have the exposure of the cook. And if you look at the orange trace, that's the temperature of the intervention stove, and then the dotted lines represents the start and end of cooking events. So you see we have one cooking event here, one other cooking event here, here and here. And then for the PM, what we did is we attributed the PM that occurred during the cooking event, we attributed them to the specific stove that were being used at the same time. But we see that there are some PM events that cannot be linked to a specific stove. No stove are being used in the kitchen at the same time, and so those we can't attribute them to any stove type. So we just put them in an other source category, and so that's what we can do for each household. And when you do that for all the 30 households in the intervention arm, out of the 6 days, you get these kind of charts that kind of summarize about 300,000 data points of measurements. And so on the left, so those two graphs actually show the same thing. The only difference is on the left it's stacked, and whereas on the right it's not stacked. And so on the left you see more kind of the overall exposure of the cook, whereas on the right it's a little bit easier to see the contribution of each source. And so the first thing that we can see is that the yellow other source category is a big contributor of the overall exposure. And so that in itself is very useful information that would have been hard to notice without doing this analysis, this kind of analysis. And then we see that the intervention stove contributes around 40-60% peak during the main cooking events, while the baseline stove is more around the 20 microgram per cubic meter contribution in average for each of those cooking events. So yeah, that's the kind of insight we can get with this method, but it's also, it raises quite a bit of questions. For example, about those other sources, what are those other sources? How can we characterize them? Are there other cooking events from other households, or are there, sources that are not relating to cooking? And so this is really something to explore. I would like to talk a little bit now about the two limits of this method. And the first one is, like we said, about those sources. This method is great to characterize, stove. We know there's a good chance that the PM that we see during cooking events are related to the particular stove that's being used. But for the PM that are not, that's not happening during a stove, then we don't really know. So ways to address that could be to use a CO sensor collocated to know whether it's a combustion source or not. Combustion would have some CO, and non-combustion source would not have any CO. Another way is to use maybe a CO and CO2 sensor together, and that could allow us potentially to identify stove signature with the modified combustion efficiency. But can we really differentiate a freestone fire, a charcoal stove, and an LPG stove based on the MCE alone? I would love to hear your thoughts on that. And what could be the influence of exhaled CO2? I don't have answers to that, but that would be really interesting to explore that. Another area that could be explored is the use of beacons to better understand the location of the cook relative to the sources. And on this note, all our sensors can actually be used as beacon. They broadcast wirelessly. And some of our sensors are getting the capability of logging beacons. And we're also developing a dedicated beacon in partnership with Berkeley Air Monitoring Group. So you can keep an eye on our website for some news about that in the future. And the last thing I would like to address is a limitation with a light scattering sensor, because their sensitivity depends on the aerosol type that we're measuring. And so if we use just one gravimetric calibration across different aerosols, we get some inaccuracies. So first, I want to point that it's the case for most collocative light scattering gravimetric system, but in our case it's a little bit more of an acute issue, because we try to characterize and quantify the contribution of each source, and so we want to have accurate particle coefficients for those sources. So one solution I'm thinking about is that we can build a better calibration model for the PM sensor. For example, instead of having just one blanket particle coefficient over a 24 hours period, we could try to calculate a particle PC for each sources and then apply them in real time to the aerosol that we detect. So thank you so much for your time. I'm really looking forward to chatting with you all and to hearing your thoughts about that. Thanks so much, and talk to you soon. Bye.